Just below Geneva, Switzerland, lies one of the greatest feats of human ingenuity, the Large Hadron Collider, or LHC. This incredible machine, buried deep underground, is more than just a feat of engineering. It's a beacon of scientific exploration. It's a testament to our relentless curiosity, our unyielding desire to unlock the secrets of the universe, and our willingness to push the boundaries of what is possible. The LHC is the largest and most powerful particle accelerator ever built. It's an incredible 17 miles in circumference and made up of a complex ring of superconducting magnets. Its purpose is to accelerate protons to almost the speed of light and smash them together. These collisions, which occur at energies that are almost beyond comprehension, allow scientists to gain insights into the fundamental structure of matter. The LHC lets us recreate the conditions that existed just moments after the Big Bang, which means we can explore the very fabric of the universe, its most fundamental particles and forces. But what if, in our quest to understand the cosmos, we're also dealing with forces we don't fully understand? The LHC has opened up possibilities that were once the stuff of science fiction. With these possibilities come questions that are both profound and unsettling. Recently, Brian Cox, a well-known figure in particle physics, made a statement that has caused a stir in the scientific community. He dropped a hint about a discovery made at CERN, something mysterious and potentially far-reaching, something that may have implications we're only just beginning to grasp. The LHC is more than just a machine. It's a gateway to the unknown. It represents the cutting edge of human knowledge, but it also raises some big questions about what it means to be human. As we continue to expand our knowledge, are we heading towards a disaster that we ourselves have created? The LHC can create energies that copy the conditions of the early universe. It can delve into the very depths of reality in ways that were previously unimaginable. But with such power comes the responsibility to ask, what are the risks? Could our experiments at the LHC accidentally set off something that could get out of control? CERN, the European Organization for Nuclear Research, was set up in 1954 and has since become one of the most respected research institutions in the world. With 23 member states and thousands of scientists from all over the world, CERN is a great example of international cooperation and scientific advancement. The LHC is CERN's flagship project, but it's just one part of a huge network of particle accelerators. These machines, despite what their name suggests, don't accelerate cars or rockets. They accelerate subatomic particles to incredible speeds, creating collisions that allow scientists to explore the fundamental building blocks of matter. The LHC is a technological marvel in terms of its design. It's located 574 feet underground, in a ring that's shielded from cosmic radiation by the Earth itself. Inside the ring, two beams of protons are accelerated to almost the speed of light. These beams are guided by a series of powerful superconducting magnets, which have to be cooled to temperatures colder than outer space, just 1.9 degrees above absolute zero. The magnets need to be kept at a really low temperature to work properly and keep the protons on their tracks as they whiz around the ring 11,245 times a second. The LHC directs these beams into 4 different collisions, which produce temperatures that are millions of times hotter than the center of the sun. It's at these collision points that the real magic happens. The LHC has 4 main detectors: ATLAS, CMS, ALICE, and LHCb. Each of these detectors has a specific job to do, focusing on different aspects of the collisions to gather as much data as possible. These detectors are like huge cameras, capturing what happens after the collisions in amazing detail. This lets scientists look through the debris to find new particles and phenomena. One of the most famous particles is the Higgs boson, which is often called the God particle. The discovery in 2012 at the LHC was a huge moment in physics, confirming a theory that had been proposed nearly 50 years earlier. The Higgs boson is a crucial element of the Standard Model of particle physics, which outlines how the fundamental particles of the universe interact. It's responsible for giving other particles mass, and its discovery was a huge step forward in our understanding of the universe. But the LHC's mission is about much more than just the Higgs boson. One of the most intriguing mysteries it aims to solve is the nature of dark matter. Dark matter is an invisible substance that doesn't emit, absorb, or reflect light, so it's impossible to detect with traditional methods. It's thought to make up about 27% of the universe, which is a lot more than the ordinary matter that makes up stars, planets, and everything we can see. The LHC's experiments are designed to produce dark matter particles in a laboratory setting, which could provide valuable insights into this elusive substance and potentially revolutionize our understanding of the cosmos. Another area the LHC is looking into is the possibility of extra dimensions. Some theories suggest that our universe may have more than the four familiar dimensions of space and time. These extra dimensions could help us understand some of the mysteries of physics, such as why gravity is weaker than other fundamental forces. If these dimensions do exist, the LHC might be able to detect them by looking at how particles behave at extremely high energies. But these pioneering experiments also come with some big risks and ethical considerations. The LHC is a very powerful tool, and there are some risks involved in its experiments. One of the most controversial possibilities is the creation of miniature black holes. Black holes are areas of space where gravity is so strong that nothing, not even light, can escape. The idea that the LHC could produce such an entity, even on a microscopic scale, has got people talking. The scientists at CERN have said that any black holes that might be produced would be unstable and would disappear almost immediately. They've carried out lots of safety checks to make sure their experiments won't harm our planet or the universe. The possibility of creating a black hole, however small, has led to debates and concerns about the potential consequences of these experiments. To understand why the LHC might create a black hole, we need to look at how particle accelerators work. When protons are accelerated to near light speeds, their energy becomes so immense that it can warp the fabric of space-time itself. Think of a trampoline that's been stretched really tightly with a heavy object on it. The fabric bends under the weight, creating a depression. If the object is heavy enough, it can create a deep well that pulls in anything nearby. This is a simplified analogy of what might happen at the LHC, where the energy of the protons could potentially create a small black hole. The LHC's experiments have even caught the attention of some of the world's most renowned scientists, including the late Stephen Hawking. In his work, Hawking highlighted a potential issue with the Higgs boson becoming unstable at extremely high energy levels. This instability could lead to a catastrophic event known as vacuum decay, a sudden and unstoppable change in the nature of the universe that could annihilate everything in existence. Another well-known scientist, Sir Martin Rees, the British cosmologist and astrophysicist, has also shared concerns about the experiments conducted at CERN. In his book, On the Future, Prospects for Humanity, Rees looked at the potential dangers associated with particle accelerators. He talked about the chance of a destructive experiment causing a phenomenon called vacuum instability. This could theoretically cause a phase transition that would affect the fabric of space-time, leading to a catastrophe of huge proportions. Despite these concerns, CERN scientists have done their best to assess the risks and say that the chance of something going wrong is very small. They've taken every precaution to reduce the risk of any potential issues, and they believe the benefits of their research outweigh the risks. The LHC has already given us some amazing insights into the nature of the universe, and it continues to challenge our understanding. As we keep pushing the boundaries of what we know, it's important to keep an eye on the ethical and existential questions that come up along the way. The mysteries of the universe are not just for fun. They are powerful tools that can help us understand the secrets of existence. But they can also unleash forces that we don't fully understand. The LHC is our boldest attempt yet to answer some of the biggest questions about our existence. But it also shows us the responsibilities that come with such knowledge. As we stand on the brink of new discoveries, we have to ask ourselves, what are we willing to pay for knowledge? Can we make sure that our quest for understanding doesn't end up causing damage? The LHC could be a game changer in how we understand the universe, but it also shows that the pursuit of knowledge comes with risks. Ultimately, the Large Hadron Collider is more than just a machine. It's a symbol of human curiosity and innovation. It shows our desire to understand the fundamental forces that shape our universe, but it also makes us think deeply about the consequences of our actions. As we push the boundaries of what is possible, we must do so with caution, always mindful of the power we wield and the responsibilities that come with it. The LHC has already achieved some amazing things, from discovering the Higgs boson to searching for dark matter and extra dimensions. But its real legacy might be in the questions it raises rather than the answers it provides. The universe is huge and still largely a mystery to us. Our understanding of it is still in its infancy. The LHC is a tool that lets us catch a glimpse of the secrets of the cosmos, but it also forces us to confront the limits of our knowledge. As we keep pushing the boundaries of what's possible in physics, we need to do so with a sense of wonder and humility. The Large Hadron Collider shows us that the universe is full of mysteries waiting to be uncovered, but it also shows us that some mysteries are probably best left alone. As we continue to expand our knowledge, it's important to remember that with great power comes great responsibility. As we look to the future and the possibilities that the LHC may unlock, we need to be careful and respectful of the forces we're trying to understand. The Large Hadron Collider is a fantastic example of what we can achieve as humans, but it also shows that the search for knowledge isn't without its risks. The universe is a huge and amazing place. As we keep exploring it, we need to be careful and think about what our actions could lead to. Ultimately, the story of the Large Hadron Collider is not just about science. It's about the human spirit, our insatiable curiosity, and our willingness to push the boundaries of what is possible. It's a story of discovery and risk, of knowledge and power, and of the careful balance we need to maintain as we explore the unknown. As we keep exploring the universe, we need to remember that there are big risks and very little room for mistakes. The Large Hadron Collider is a powerful tool, and it's down to us to use it wisely.